right, this is 9.3, the law of cosine. So the law of cosine is used for cases when we don't use the law of sines. So there's two cases when we use the law of cosines. That's when we have side angle side, which is SAS, or when we know all three sides, which is side, side, side. So I like to tell people it's a sassy snake, because SAS is sass. Sassy snake, that's when you use the law of cosines. So SSS is like the hiss a snake makes. All right. So the law of cosines, there's three different ones, and depending on what you're given will be what you use. For instance, the first one says c squared equals a squared plus b squared minus 2ab cosine c. So when you use this one, you more than likely will know a, side b, and angle c. Okay, for the second one, it's b squared equals a squared plus c squared minus 2ac cosine b. So that's a case where you'll know what a is, what c is, and what angle b is. And finally, a squared equals b squared plus c squared minus 2bc cosine a. You're going to know side b, side c, and angle a to use it. So let's see this in action. All right, it says solve the triangle, and it says that side we have A, C, and B angles, and side A, B, and C. So the first thing I'm going to do is actually notate it. So the side across from angle A is side A, so A equals 4. We have side B. The angle across from side B is angle B, which is 45 degrees. And C, side C, is across from angle C. So we know that side C equals 5. Okay, what kind of a triangle is this? This is a SAS, S-A-S, side, angle, side, because the angle is sandwiched in between the two sides. And therefore I know that I should be using the law of cosines. So now my next step is to figure out which one do I use. I have A, I have side C, and I have angle B. So what I'm going to do is I'm actually going to go after side B first. So this is side B we're looking for. B squared equals A squared plus C squared minus 2AC cosine of angle B. All right, so we're going to plug some stuff in. So we have 4 squared plus C, which is 5 squared, minus 2 times 4 times 5, cosine of 45 degrees. And this equals B squared. Okay, so we do the math. 4 squared is 16, 5 squared is 25, and then 2 times 5 is 10, 10 times 4 is 40, cosine of 45 degrees. And this equals B squared. Okay, I'm going to add a 16 and 25 together. That is 41, so I get 41 minus 40, cosine of 45 degrees. By the way, I cannot take and subtract 41 and 40. The reason why is because that 40 is attached or multiplied by cosine of 45 degrees, so don't do that. Okay, so now what I'm going to do is to solve for b, I'm going to take the square root of the side. So in your calculator, you're going to take the square root of, and I'd use parentheses, 41 minus, and then parentheses again, 40 times cosine of 45 degrees, and the parentheses, and stick the other parentheses there. And when you do that, you'll see that side b equals 3.6. I rounded that to the nearest tenth of a degree. Tenth of a value, not a degree. Okay. The next thing I'm going to go after is angle A. So to get angle A, I have to use this formula. A squared equals B squared plus C squared minus 2BC. That's right. 2BC cosine of angle A. Sorry, I doubted myself for a moment there. All right, so I'm going to plug and chug. A is 4, so I'm taking 4 squared, which equals B. B is 3.6 squared, plus C squared, which is 5 squared, minus 2 times 3.6 times 5 cosine of angle A. All right, 4 squared is 16. 3.6 squared gives me 12.96, plus 5 squared is 25, minus I have 2 times 5, which is 10, and 10 times 3.6 gives me 36, cosine of A. Okay, so now I'm going to add 12.96 plus 25, which gives me 37.96 minus 36 cosine of A, and it equals 16. Now my next step is to subtract 37.6 or 37.96 from both sides. So if I take 16 less 37.96, I'm going to get a negative 21.96, and that equals negative 36 cosine of A. Next step is to divide both sides by 36. So I get negative 21.96 divided by negative 36 equals cosine of A. To get cosine by itself, I'm going to have to take the inverse cosine of both sides. So this equals cosine inverse of 21.96 divided by 36, and that's going to give me angle A. And when I do that on my calculator, and by the way, my calculator is in degrees, I get the value of angle A equals 52.4 degrees. Guys, I would highly recommend with these to pause the video, work out the values, and see if you get the same thing as me. Alright, so we have one more bit to get, and that is angle C. Angle C I luck out because I can use the value that the interior angles of a triangle sum to 180 degrees. So what I'm going to do here is take 180 less angle B, which was 45 degrees, less angle A, which I just found, which was 52.4 degrees. And when I subtract the three of those, I get 82.6 degrees, and that is angle C. I do want to make a note here. If you start with law of cosines, you cannot mix and match. So you can't use law of cosines if you start out and then change to law of sines. You're not allowed to do that. That will lead to lots of trouble. So we're going to make a note here. Once you start with law of cosines, you stay with law of cosines. And a couple of you might be wondering why that's the case. And the case is, if you remember that inverse cosine, the angles were in quadrants 1 and 2. And inverse sine, which would go with the law of sines, is in quadrant 4 and quadrant 1. So what happens is sometimes you can get a domain error. So once again, if you start with law of cosines, end with law of cosines. Okay, so we're on the next page here. It says to solve the triangle, we have to first figure out what we have. So the side opposite to angle A is side A, so A equals 5. The side opposite to C is 7, so side C equals 7. And the side opposite to angle B is side B, which equals 6. Since I know all three sides, we have side, side, side. Remember sassy snake, that's law of cosines. Okay, so it doesn't really matter which one I go after because I don't know any of my angles. So I'm going to just go after angle A first. So angle A is A squared equals B squared plus C squared minus 2BC cosine of angle A. Okay, so A squared is 5 squared, B is 6, we're going to square that, C is 7, we're going to square that, minus 2 times 6 times 7, cosine of A. Alright, so 5 squared is 25, 6 squared is 36, 7 squared is 49, minus 2 times 6 times 7, that'll give me 84, cosine of A. Alright, so we're going to add the 36 and the 49 together, and when I do that I get 85, minus 84 cosine of A. So I have 25 equals, or actually, let's stop there a minute. We're going to divide, or subtract, sorry. I'm going to actually subtract 85 off of both sides. And when I subtract 25 minus 85, I get negative 60. So I have negative 60 equals negative 84 cosine of A. Now I'm going to divide both sides by a negative 84. and I get 60 over 84 equals cosine of A. Now, in order to get A by itself, you take the inverse cosine of 60 divided by 84, and that'll give you A. So when I do that, I get 44.4 degrees, and that's going to be my answer for angle A. All right, so I have 2 more angles to go. So I'm going to go head after angle B. To get B, I have to use B squared equals A squared plus C squared minus 2AC cosine of angle B. By the way, look, I'm looking for angle B, so B squared's on the other side. That always happens. So if you're looking for angle A squared is isolated. So I just wanted to point that out really quick. All right, so let's do this. B is 6. 6 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine of angle B. This is 36. It equals 25 plus 49. 2 times 5 is 10. 10 times 7 is 70. So minus 70 cosine of angle B. Okay, now I got to add 25 and 49 together. That gives me 74. Minus 70 cosine of angle B equals 36. Now I'm going to divide both sides. Excuse me, I'm not going to do that. I'm going to subtract 74 from both sides first. So when I subtract 74 from both sides, I get negative 38 equals negative 70 cosine of angle B. Now dividing that off, we get a little value. It's 0.542857, and that equals cosine of angle B. I have to take the inverse cosine of both sides. And when I do that, I get B is equal to 57.1 degrees. Okay. So now I have one more angle left, that is angle C. And to find angle C, I am going to use the interior angles have to sum to 180. So I'm going to take 180 minus A, which was 44.4 degrees, minus B, which I found out to be 57.1 degrees. And when I subtract those, I get 78.5 degrees, and that is angle C. So if I wanted to check myself, I'd have to add angle A, angle B, and angle C, and that better equal 180 degrees. All right, moving on. Okay, the distance from home plate to a fence in dead center at a certain baseball field is 409 feet. How far is it from the fence to dead center of third base? All right, so they drew this diagram here, and we know that this side is 90 feet exactly, and the other one was 409 feet. So let me make that a little bit darker. All right. So I have 2 sides known, and if it's a perfect baseball diamond, half of this angle here would be 45 because it makes a square, and a square has right angles. So I know that's 45 degrees. So if I redraw this really quickly, I get 90, 409, and then 45 here. So I know this is a side angle side, which means I have to use the law of cosines. Whoops. I don't know what happened. There we go. Law of cosines. Okay. So I'm going to label some stuff really quick too. I'm going to fix this pen really quick. Okay. So let's say I'm going to call 45 angle A. So therefore side A, I don't know. And I'm going to call angle B right over here. So side B is 409. And angle C is going to be up at the top. So side C is 90 degrees. Okay. So being that said, I have angle A, we have side C, and we have side B. I'm looking for side A because it said how far is the fence to dead center to third base. Okay, so if I'm looking for A, I'm going to use A squared equals B squared plus C squared minus 2BC cosine of angle A. All right, so let's plug and chug. A squared equals B is 409. We're going to square it. Plus C, which is 90 feet. We're going to square that. Minus 2 times 409 times 90 times cosine of 45 degrees. Okay, ran out of room there. So A squared equals, when I square 409, I get 167,281, or 167,281, plus, if I square 90, I get 8,100, minus 2 times 409 times 90 will give me 73620 cosine of 45 degrees. Okay? All right. So I got to add 167,281 plus 8,100. And when I do, I get 175,381, or 175,381. And then if I take 73,620 times cosine of 45 degrees, I get 52057.20123. Let's make that point there. So that's 52,057.20123. Now what I'm going to do is take the square root of that, and that's going to equal A. So side A ends up being 351.2 feet. Okay, big numbers. You might have to pause the video. That's fine to get them all down. All right, so here's the next one. This one actually requires more work than the last one. We have to do this in bits and pieces. A cruise ship maintains a speed of 70 knots, that's nautical miles per hour, sailing from San Juan to Barbados, a distance of 600 nautical miles. To avoid a tropical storm, the captain heads out of San Juan at a direction of 10 degrees off a direct heading to Barbados. The captain maintains the 17-knot speed for 10 hours, after which time the path to Barbados becomes clear of the storm. Part A. Through what angle should the captain turn to head directly to Barbados? Part B. Once the turn is made, how long will it be until the ship reaches Barbados if the same 17-knot speed is maintained? Okay, so we have the distance from San Juan to where the boat is. Remember, he's gone 17 knots per hour for 10 hours. So 17 times 10 is 170. All right, so if I redraw my triangle, I get 10 degrees here, 170 miles there, and 600 miles per nautical per hour over there. Okay, so let's label these. I'm going to call A the 10 degrees, so it's angle A. Side C is going to be 600. And then side B is going to be 170. Okay, I need to find side C, but I can't do that right now because I don't have side A. So I'm actually going to have to look for side A first. Okay, so first of all, before I find side A, I know I have SAS, which means law of cosines. So I'm going to go ahead and I'm looking for side A, so I have A squared equals B squared plus C squared minus 2BC cosine of angle A. All right, plug and play. A squared equals 170 squared plus 600 squared minus 2 times 170 times 600 times cosine of angle A, which is 10 degrees. Okay, A squared equals, if I square 170, I get 28900, or 28,900, plus I square 600, I get 36 with 4 zeros, 360,000, minus, if I take 2 times 170 times 600, I get 204,000 cosine of 10 degrees. Okay, moving on. A squared equals, now I'm going to add these two together, which is 28,900 plus 360,000, and when I do, I get 388,900, and then if I multiply 204,000 times cosine of 10, I get 200,900.7816. Okay, so 200,900.7616. Okay, so to do the same trick, take the square root of that. And I get A is equal to 433.6, which I'm going to round to the nearest mile, which is 434 miles. Okay, so we know like the distance, or I shouldn't say the distance. Yeah, I do know the distance from the ship to Barbados. So we know what that is. Now that I have side A, I can put that up here, 434. I'm going to have to look for angle C. So angle C, I'm going to have to use law of cosines. Remember, if you start with it, you end with it. So I get C squared equals A squared plus B squared minus 2AB cosine of C. Okay, plugging in large numbers, I get 600 squared equals 434 squared plus 170 squared minus 2 times 434 times 170 cosine of angle C. Okay, so we get 36 with 4 zeros equals 188356 plus 28900 minus 147560 cosine of C. So I'm going to go ahead and put in commas just so it doesn't look so messy. Okay, so we got that. Doing a little bit of math, so I'm going to let you work out that part. So if you need to stop it, you can. But I'm going to get us down to 142,744 equals negative 147560 cosine of C. Basically what I did was added the two numbers, subtracted them from both sides, right? Okay, so now if you divide off negative 147560, I get negative 0.9675624288, and that equals cosine of angle C. Okay, so when I take inverse cosine, I get C equals 165.3. 165.3. So once again, you might have to stop the video to work out those numbers. Okay, but that is not my answer, because for part A, it asks us what angle does a boat need to go. So if you look over at the original thing, we're looking for that. I know that this creates a straight angle. So straight angles are 180 degrees. So if I take 180 degrees minus angle C, which I just found, I should get the angle that boat needs to rotate. So 180 minus 165.3 will give me 14.7. So that is, for part A, that is the answer. 14.7, that's the angle in which that boat needs to rotate. Okay, for part B, it asks us, once the turn is made, how long will it take? Well, I know the distance because I found that. The distance was 434. So if I use the formula distance equals rate times time, I get 434. The rate is still 17 knots speed, so that's 17 times your time. Okay, so 434 divided by 17 equals T. Your time equals 25.5, so 25.5 hours. Okay, and that's that. So we're done with section 9.3. Make sure you watch the next one as well.